Look at this. It's a new module, ladies and gents. Yay! We're going to be talking about containers and algorithms in the standard library, more commonly known as the STL. It's the theme of the next few weeks. So yeah, it's hopefully going to be quite interesting. You've all been here before. I don't need to go over this again, do I? Oh no, maybe we haven't all been here before. No, we have a new face in the corner. Sorry. Yes, so Slack is like a chat application, modern version of IRC, I guess. And there's a CPP Lang channel for talking about C++. It's got a couple of thousand members on there. We've got our own room, #CPP London Uni. So if you want to join us, and I encourage everyone to do so, if you go to this URL and pop in your email address, and it will send you an invitation to the exclusive club that is the CPP Lang Slack channel. So, awesome. Next note, who's heard of Advent of Code? None of the rest of you. Okay, so Advent of Code is a series of daily challenges, like sort of programming challenges. And it's very much along the same lines as Code Wars or Hacker Rank or something like that. It's got, it gives you a little bit of a silly backstory and then a task, and then gives you some inputs, and you have to write a program that solves the problem, and then submit your solution, submit your output, and it will tell you if you got it right or not. It's running for 25 days, so it started on the 1st, but you can go back and do the old problems. That's no problem if you want to start now. Runs until Christmas Day. You go to adventofcode.com and you can sign up there. I've had a look at the first few days, and it seems pretty good. I'm quite impressed. And actually, you can go back and do all the previous year's exercises as well. So they started in 2015, so you've got 15, 16, and 17 to do as well. So there's loads of really good problems on there. And in particular, it's quite a good opportunity to use the things we're going to learn in this module. So if you fancy it, it'd be quite a good thing to work through on Thursdays, I think. People who come along to the Thursday sessions.
When you say good, is that how
well, the first 3 days, it gets harder as it progresses. So I don't know what's going to turn up on the 24th. Probably something really difficult. I've got no idea.
so it's a progression.
Yeah. It has this facility so there's an overall sort of global leaderboard, which, obviously there are thousands of people doing that. But it has a facility to set up private leaderboards as well. So I've set one up for us. You need to, once you're logged in, copy and paste the code to join the private leaderboard. I've put the code in the Slack channel. I don't want to put it on the slides because they go out to the general public. But if you are in the Slack channel, you can just have a look up at yesterday's messages, and it's in there.
Should point out the leaderboard to just whoever does it fastest. Like whoever gives the correct answers fastest.
Yes. Whoever solves it first gets the most points.
Which does kind of mean that using C++ isn't your best friend technically.
Well, yeah. Also, they released new problems, I think, at midnight US East Coast time, so it's about 5 a.m., 6 a.m. for us. So it's not great. But still, I think Advent of Code is pretty good. Go do it, join up, have a look at the problems, have a go at them. I can recommend it. So that's that. So last week was the end of the previous module. So last module was all about custom types, all about writing our own structures and classes and things like that. So we talked about, we had a little brief bit finishing off about explicit constructors, talked about public and private member access, we talked about friends, and then we gave you this end of module quiz that people didn't like very much.
No, it was just the time.
Yeah, there was some time pressure. I now yacked for a bit longer than I should have, and you guys didn't have enough time really to do justice to the quiz. So we're going to give you another go.
See if
Can we not see what we got for the first one?
Sorry?
Those who did, can we not see what we got for the first one?
It's the same. There's no. It's the same quiz. So if you do,
So what did we get? The mark.
that's well. You can.
Well, if I give you marks, it gives you answers. So I didn't give you marks because you
Yeah.
don't want answers
Because there's no way of giving you the answers without, we want to give you feedback, and so you can have another go at it today. We'll give you some time to do that, and then Ollie's going to go through the solutions.
Yeah, so basically, if you don't want to do it, don't have to. I will mark your old one. So
If you don't want to redo it, you're welcome to go and get some pizza and a beer.
Are we getting more time this one?
That's the idea.
Yes. And then Ollie's going to go through the answers, and then I'm going to begin talking about the actual theme of this module, which is what's called the standard template library, the containers and algorithms part of the C++ standard library.
Is
Yes.
there any plug points around this room that I can plug my laptop into?
Yeah, we just check it.
There may be.
There should be a cable cord somewhere. You took it, I know, I brought one in it.
There was one after that one here.
Right, I've got the shortened URL.
Is it the same as last time? Oh.
Yeah, I've got it. I will paste it to the CPP London Uni.
Is this one Y, I, F, J, S, etc.? Or is there a shortened one? Is there a shortened URL?
That is the shortened URL.
Oh.
Do you want even more?
Oh, last time you used some
Yeah, we'll put it on.
tiny.cc, yeah. Can I exactly replicate that photo, do you think? That's sort of... No, don't do it, Justin.
There you go.
Okay, so this is the new URL for the test. So please go there. We'll give you a more generous time limit this week.
We reckon for roughly 45 minutes.
Well, let's say 40 minutes. We'll give you till 20 to 8. And hopefully you'll be happier this week, because we were a bit mean last week.
Fell off. I'm doing it. It's coming from my head. Seems to go to that. It's going to cost you much.
So the part string, each vector is a string, so it's A vector. So each dot will multiply by C together. So each column is A, B, C, D.
So I could just do it at school.
Yeah, which is
No, I just thought you could be able to have it. she's doing it.
So it's just a list of
Yeah,
cars.
she's sending back. It's kind of like what happened.
And what I did, I'm trying to do the object movement. So I made a, I wanted to just generate a so I did, I made a class, I made a constructor, and inside that constructor, I converted string.
Okay, does anyone still need the URL, or can I take it down? I take it down? I'm taking it down. 1940. Cheers.
We need to go through some CPP records, deleting from vectors.
Not today. Next week. No, it's going to be a very high level introduction today.
No worries, it's great. We have also this wide use thanks to looking goes on. But
Last session was great. Some nice low level thinking. Again, thank you.
Cool. Thank you to whoever that was.
Carry back.
by default.
Especially design.
It was this
I'm saying that when that handle was created, by default, it's not a handle at all.
why
It's just null. So to give it some value, and give it a value, it's not going to Getting along okay? Ready to submit? Who thinks that they'll be done soon? Who needs loads more time? Nobody needs loads more time. Good. So I should go through the answer, shouldn't I?
Yes, I assumed you would. I've got it up on a browser window here if you want.
Yeah, that's good. I'm just gonna get rid of it. Okay, I see 5 responses so far. That's fine, right? Who has not submitted their answers? 1. Everyone else has submitted their answers? Who is not doing the test anyway? Who is still doing the test?
I don't want to submit because I want to use my last week's results.
Ah.
Because we submitted last week as well.
Yeah,
Just
that's
use
fine.
last week, yeah.
That's fine.
I was just
If
looking
you're
over
happy, no, if you're happy with last week's, it's fine. So Sard is doing the test.
Just need one then.
Who is not doing the test? Cool.
It's this one.
I can't remember.
Oh, so
I can't
this
remember
one
what I did.
screwed.
Yeah, I can't remember.
I looked at this one here. I was like, what the hell am I doing here? So I couldn't bother. This one here. I wasn't sure about the last question. I've still got my what over the last weekend, so it doesn't matter. So this one here. This is ridiculous. I was like, what? I didn't even know this was a thing. A double.
Reference of a reference. Right.
I don't know.
No, I didn't get confused with the last week.
Let's do that. Is that fun? What was the last one? What do you think about trying to be money to something? So these are the results. Huh? Oh crap! I put that one down. So we can actually. Oh, it's time for giving it down. Giving it down.
look, because that was like, one and a half,
What did he say?
You don't want to debug. Just rust live.
Nothing's changing, it doesn't it? It should be bound the same.
Well, that'll be the secret
Right.
actually, won't it?
Yeah. You've heard me never seen anything like that.
So everyone's done? Yeah, I'm going to close the test now. And it's closed. Right, should we get through the answers?
Okay, how do people feel about that this week?
Good.
Better.
Happy. Alright, so let me take
Tom, can you make sure this is going out?
So, you want this to be seen or not?
Hmm?
Do you want this to be seen or not?
Yeah. Ollie's just been called off on a call, so we'll wait for him for just a minute.
Yeah, sure.
So, okay, test is now closed. Obviously, if anyone's watching from the internet and you want to take the test, because I can reopen it for you, please message me on Slack and stop watching the video now, or you will know all the answers. And there is no point taking this test if you know all the answers. You don't get anything for it. Right. So select the option that is true about public and private. Fairly simple multiple choice. Show of hands, who found this one easy? Okay, wow, okay. Only a few of you. So the options obviously are public is visibility to anything outside the type, and private is used for dummy or unused data. Well, no, it's dummy or unused data. Public gives visibility to anything outside the type, and private is simply only visible inside the type. Of course. This was obviously wrong because it inverted it. Private clearly doesn't mean anything outside, and obviously they're not the same. What would be the point of having how public and private doesn't mean the same in the English language? Why would it mean the same in C++? So then we had select the option that's true about the friend keyword. The first one was a friend is able to access the private protected things of the friend. I will apologise in advance for reading these out to myself because the survey shows in randomised order. That or I've forgotten one of the two. Anyway, so friend is able to access the private or protected things of the friend, declaring type but only in that one direction. That is the one. Then just to try and see who fell for it, I had a friend is able to access the private protected things of the friend, declaring type, and it also becomes able to access the private protected things of the friend. This was the longest answer, but it was actually completely false. It does not work in both ways because it would allow you to punch a security hole in other people's code, which would obviously be bad. If you simply say they're my friend and you can access their stuff, that's a security hole. They didn't agree to that. And I mean, it's fairly obvious that a friend is not able to loan the other class a kidney if it needs one.
Can you ever loan a kidney?
Hmm?
Like a loan would imply you're going to get it back at some point.
That's a good point. I mean, maybe
Give a kidney.
classes obviously can regrow kidneys. So. So which term describes things like operator equals equals, operator equality, or operator plus? And please say you got this one right. This was easy enough? Yeah? Which one do you think it was, Sard? Picking on you.
Operator overlay.
On your mouse.
Just the one that my mouse happens to be hovering over. So, I mean, that was the real test. Like, did he see where the mouse was? Okay, so consider the following code. So we have a struct, which we've called capital A. Just an A in capitals. It has a member function called fn, which takes an int and returns a std string. And we have a constructor, which takes a reference to a const std string. And then we have implementations for it. So we have the member function fn. Sorry, that's not true. Completely died. We have a free function fn, which takes a reference to a const a, and we call it x. The body of the code didn't matter, so I just put a comment in there. And it's supposed to return a std string. And then, of course, we had our a fn, which takes an int and returns a string. The body of the function was not relevant. So then we said which one's true. So the first line after begin defines a class struct member function. Well, no, it's not true. That's a free function. Both lines after begin, no, still not true. So obviously the first line after begin defines a free function, and the second line defines a member function. So you can look at it fairly quickly, and that pretty much gives it away, doesn't it? So then we had select all statements that are true. So this was worth 2 points. So hopefully you figured out there are 2 correct answers.
Well, I think there's this or, it also implies that there's more than one.
It does, potentially. So the class member function is accessed by using the dot operator on a value or reference type. That is true. The class member function is accessed by using the dot operator on a pointer to the type. That is not true. Class member function is accessed by using the arrow operator on a value or reference type. Nope, because that would contradict what we selected there. So it's obviously this one. It's accessed by using the arrow operator on a pointer. So if you have the object itself or a reference that you've declared, use the dot, and if it's a pointer to it, then use the arrow. So then we had select the correct option that would call a member function fn from within another member function. And of course the correct answer was using this. Due to historic reasons, this is a pointer to our type, so you have to use the arrow. Sadly, it's not a reference. This would be nice, arguably. This is what we should have in many respects, but it's not what we've got, so that's the correct answer there. Which keyword on the constructor of A would prevent the first function after begin from constructing directly from an int? So hopefully you all listened to Tristan on that final session and selected explicit. Obviously, no except is related to exceptions. Direct is just garbage. And this is not true. The bottom option is not true at all. Okay, so we have write the declaration for a member function overloads the equality comparison operator for its own type, which we're going to call T, ensuring const correctness. So I said write the declaration. So there's a few ways you can essentially write the declaration, given that it would be within the scope of a struct. So the ideal way you would write it would be to have struct T. This is just one of the solutions. This is one of the ones I have to manually mark. And we said that it will overload its equality comparison, so it needs to return a bool. And then of course we have operator equals that's the comparison. It will take a const T ref, and we'll call it X for simplicity. It doesn't matter what you call it, obviously. X or right hand side or other, whatever you want to call it is fine, as long as you keep it correct. And then, and then we need the const qualifier, because obviously you should be able to compare them when they are const. Oh, yeah, sorry, that's a typo. That was a typo, sorry. That was all you needed, sorry, it was a declaration. That was it, but there we go. So, just to be really correct. So you have the complete struct T you've declared there with a member function that is returning a bool, is the operator equality comparison, takes a const T ref, and in fact technically you don't even need that, just make it even shorter. In the definition you can give it a name instead. So it doesn't hurt, you can have, if you have one there or you don't, it doesn't matter. So this is correct, this is also correct, because it's declaration.
You did mention that you could create the struct itself.
No, I won't fail you for that. So I just did it to be really, really correct. You'll get full marks for just that. So consider the following struct. So we have our fairly long here struct file manager, and I've peppered it with some comments to try and explain the semantics that hopefully you'd have read. So we have this file handle type, which could just be an int really. It just is a number. And we assume that this is default empty. We have a boolean for checking if we've released the file back to the operating system. We've closed it. We have a explicitly defaulted default constructor. We have a constructor that is non-explicit but takes a constant string ref as a parameter, which is arguably kind of handy because you can obviously construct it from a char star as well. Actually, no, sorry, I'm getting confused now. This is something else, ignore that. And it initializes the handle with some pseudo-imaginary function called open file. and it just uses the file name to open it. And in the destructor, it checks if is released is not true. So if it's false, then it will close the handle. And then of course we have an assignment operator, and then there's a few bugs littered through this that you were asked to find. So first of all, though, you say what's the starting line number of the default constructor? Hopefully you chose line 6. It says default, doesn't take any arguments. That's the default constructor. The starting line number of the destructor. Well, obviously it's this tilde. That's on line 10. So the answer is 10. Then I said select the variable options to replace line 6 with in order to delete the default constructor. So there are 2 ways you can actually do it. So the first one is this answer, just delete the line. So we currently explicitly default it because this constructor would otherwise make it go out of existence. So this is to bring it back into existence. So you can just delete line 6 and boom, no more default constructor because this exists. If you don't have any constructors, then you get one by default, providing all your members are default constructible. The second way is this one. You can just change the word default to delete, and that means bye-bye, gone. Can't use it. So those are the 2 options. Next question was, is there a bug in the destructor? Well, let's have a look. So, well, we check if it's released. If is released is false. So when we construct, yes, it would have been false. There's nowhere in this code that will ever set it to true, but that's a different issue. But we know it must be false. So, okay, we'll close the file. But what if it's already closed? You know, what if operator equals, right? So someone moves from us, someone takes our handle. You don't want 2 instances of a class to have the handle open. That's bad, right? You can't both close the file. What?
So somebody invokes the default constructor.
Or if someone invokes the default constructor as well, correct. Then your close file will crash because it says assume this function requires a valid file handle that is open or it otherwise crashes. So you have 2 possibilities to crash. Someone uses the move assignment operator to take your handle, or you just default construct it. You can't do anything with it when it's default constructed except for take from another one. But if you just simply construct one without using it ever, it will immediately crash when it's destructed because this is not valid. So the fix, of course, is that we should check if the handle is valid. So if exclamation mark is released and handle, and that would fix it. So where was that? Sorry. So we could say something like that. Doesn't have to be exactly that. I can read English, so as long as you wrote your answer in English, I'll understand. So then I said there were some bugs in operator equals. So this is obviously oh no, sorry, just one question. So there's a couple of bugs, and I asked you to tell me one of them. So there are there's actually 2 bugs I built into it. So or possibly more. Anyway, so we check if the other one is empty. That's good, and if it is, we just return. Cool, fine. Otherwise, we take their handle, but we don't actually clear their handle in any way. So I didn't tell you what you could assign this to, so a default constructed file handle would be fine, but if you use something like null pointer or whatever, I'll give you it, as long as you convey the meaning.
Could you explain what line 16 is doing? I was kind of stuck on that.
So
I know that's if
So
statement.
imagine that this is some type that could be false, or if it's not a handle to an actual file, then it will be false.
Yes.
So it's
makes it true.
Sorry.
So this if statement will make it true. If it's false, it'll make it true, and then run the return.
Yeah, it inverts the logic and then it just does nothing. The point is that this does nothing. If the thing we would move from doesn't have a handle to take, there's nothing to do.
Yes.
So anyway, that's fine. That's not a bug. That's not a bug. That's correct.
I just want to know why it does.
Okay. So then we have the assignment of the other one's handle. What we don't do is we don't unset it. So that means that this guy, this other, when he gets destructed, he doesn't know that even if we fix the destructor, say we fix the destructor so it does check the handle, it's going to close it anyway, which is bad. We're still using it and it's going to close it. So one of the fixes to this bug that I put in here was that other.handle equals null, or a default constructed file handle, whatever you want, was one of the fixes. And then the other bug was yes, was the is released. So we take the other one's handle, and that's another way of fixing it. We don't actually copy the released state from other either. So we don't take their is released state, because they may have a valid handle, but it may have been released. And we don't set their released state either. So the idea was that we would take their current state, which, to be honest, if there is a handle, it probably shouldn't be false, but irrespective of that, the point was that you should set theirs to true. So let's actually do the implementation of it. So I will first of all copy the content. So the first thing I hope you did was, and it's okay if you copied the line numbers, it doesn't bother me at all. So we copy the code, and then go to the answer, paste. Lovely, that didn't copy very nicely, but let me just get the comments, it should look a bit better then. Okay, so if not other.handle, return this. Then we had handle equals other.handle, so then we could do other.handle equals that. If you did null pointer or 0, that would be I wouldn't mind that either. The point is to demonstrate you understand that it needed to be cleared. And then what was the variable called again? I've forgotten. It was is released. Oh, where is that? There we go. Is released equals other.is released. And finally, other.is. You could use std swap if you want to be fancy. Other.is released equals. And then finally the return starts.
So what happens if we've got a valid handle?
What do you mean?
At the moment, we've got a valid handle. Don't we have to call
Oh, sorry, I completely forgot that. That's one of the ones I noted down. Yeah, sorry.
So swapping our handle with others' handle would cover that.
So the wait, you can just do this. Wait, what keyboard layout have you got? Oh boy. Oh, here we go. What do I call this again? That was it. So it's one of the rare cases where you. Ah, sorry. Just make it more explicit. So you can just call it Destructor, assuming you'd fixed it. But semantically, you can just call it Destructor. It will either do something or it won't. And that was it. So just to go over it, obviously the lines of numbers are the original lines. They didn't need fixing. So if there's nothing on the other one, do nothing. Otherwise, destroy our handle if we have one by calling the Destructor. Grab the other one's handle, nuke the other one's handle, grab the release state, set their release state, and finally return a reference to ourselves. And then, of course, the final question was just for us to judge how you think you did. See if your expectations lined up with how your score went. So now I will fill these all out. If you did do the new one, I'll mark the new one. If you didn't do the new one, I'll mark your old one. If you didn't do it at all, then there's nothing to mark. Thanks, everyone.
Cheers, Ollie. Thank you. Yeah, that file handle question was a bit nasty, but if you managed it, very well done. Okay. Right. Any final questions? No. Good. Excellent. Let's talk about some new things. Let's talk about the standard template library. Or rather, Let's not yet. Instead, let's think about some code problems. Let's think about this sort of quite pertinent example. We have a vector of test scores, which stinks. Bunch of test scores for every student in the class. Maybe every student who's taking a GCSE, whatever it is, doesn't matter how many there are. These tests are marked out of 10. We want to find out how many students scored a perfect 10. This is something, if you've been coming to these classes, it's the kind of thing I might have set you as a homework in an early session. So let's have a think about how we can do that. Let's have some suggestions.
Or if it's greater than 10, let's put it into another vector string.
So imagine we've got a vector event called schools. Const there is not strictly necessary. You can modify this vector if you want to. How would you? What's the fundamental thing we're trying to do with this? Yeah.
Count it.
Count it. Absolutely. Yeah. We want to count how many tens there are in this vector.
So we just iterate over the numbers and count 10. We can have a variable that's called out here.
Just use count.
Called 10.
Num tens, for example.
Yeah, and if you iterate through the vector, every time you come across a 10, you increment numbers 10 by 1.
Perfect. Absolutely. That's what we need to do. So we create a variable to record how many tens we've seen. And then we use this range for loop. You could do it with an old school for loop. You could do it with a while loop. Any number of ways you could do it. This is one of the easier ones. We use a range for loop to iterate over every int in this array. So for every int I in scores, if I is equal to 10, we increment our 10 counter. And that's fine. Nothing wrong with that at all. It's fast, it's efficient, not using any more memory than we need to. We're only looping through all of the variables once. We're not going back and forth, jumping around in our vector. We just start at the beginning, zip through right to the end. Great. So now let's have a look at another problem. A list of dog names. How many people were really boring and unoriginal and called their dog Rover? This time we've got a vector of strings. So how do you think we solve this?
But we've got to be careful how Rover is spelled in the list, surely. Some might spell it all R. Not spelling this thing R-O-V capital V.
That's true. If you wanted to do a case-insensitive comparison, that would probably be a good thing. We're going to assume everyone's typed it with an initial capital and lower. So this time we have a variable, numRovers, and we iterate through the list of names. So this time I couldn't be bothered to write const standard string ref. We want to capture by reference here because copying a string can be an expensive thing to do. It can be an allocation, we don't want that. So we just capture by const reference because we're not modifying it. If the name is equal to Rover, we increment our Rover counter, our numRovers. And again, this is great. Zip through the array, no copies, no more memory than we need to use. This is good.
Very quick question. I get the reference constant auto reference part, but wouldn't the names, the vector itself being copied in this range for you?
No, it's not. It's the short answer. This is like an existing variable, so when you use the name there, you're not introducing a new variable. This is just a reference to an existing variable.
Congratulations to one of our respondents who got a perfect score.
Somebody got a perfect score. Oh, Well done to whoever that was.
I won't say the email, but Andy. That's all I'll say. Congratulations, Andy.
Well done, Andy.
Yeah, Andy Bond.
So this is pretty similar to what we had before. We're iterating over strings and we're searching for something different, but fundamentally it feels the same as what we're doing before. We're just counting the number of instances that are equal to something. Let's have a look at one more. We're writing some home automation software. You know, smart light bulbs or whatever. Doesn't really matter. We've got an array of 6 light switches. These light switches can be on or off. We want to know how many of them are in the on state. So we can represent that as an array of 6 bools. This, if you're not familiar with it, standard array is a fixed size array type, as opposed to a vector which can grow and shrink. An array always has exactly 6 things in it. You can't add things or take things away. So this is a fixed array of 6 switches. Each one of those can be on or off. We represent that as a bool. True means on, false means off. And you can probably imagine what we're going to do here. We can loop through all of the bools in this array. So for every bool B in switches, if B is true, well, we don't have to write all that, we can just do if B, because B is already a Boolean. We increment our counter of the number of active switches. So again, this fundamentally feels like we're doing the same thing. Now, we've got a different value type, and in fact, we've got a different collection type. We're not using a vector anymore. This time we're using an array.
Question.
Yeah.
I would like to know as well how many is inactive. What would be the best way? Create a separate variable like number inactive, and then take them, add them, increase the number.
Well, once you found out how many are active, it's pretty easy to get the inactive ones.
Or just
It's
take
just
away.
6 minus the number of active ones.
So that would be okay.
This is completely an imaginary,
Yeah.
imaginary problem. So this loop here, this initializing a variable to 0, looping over something, and every time we find a particular value, increment our counter. This is repeating and repeating and repeating. This is a really common thing to do. We have the same requirement for each of these problems. We want to count. That's exactly what you said. We want to count the number of elements equal to a certain value. And there was nothing really wrong with any of those solutions as one-offs. They were all, perfectly good code. You wouldn't be able to write it more efficiently than that. But we had to write the same thing over and over again. And if you've read about any sort of programming principles before, the thing that comes up over and over again is code reuse, or alternatively put, don't repeat yourself. DRY. It can often be, usually is, a good idea to find, if you find you're doing the same thing over and over again, to try abstracting that into a function. And yes, counts was a very simple example. We can write that loop and we can look at it and we can convince ourselves that that's okay. But if you're doing something more complicated, well, you're going to squint at it and think about it and have to really convince yourself that what you've written is correct if it was a slightly more complicated example. And then perhaps one of your colleagues has done another implementation that does fundamentally the same thing, but you know, they've structured the code a little bit differently. So then you've really got to squint at that and go, well, does that thing do the same as this thing over here? So wouldn't it be good if there was a library available that provided a count function for us? Count function and lots more besides. Wouldn't that be nice? So let's imagine some library like that exists. It's called this. So now we have our get scores. And we can do this. We can just initialize a number of 10s just by calling count in scores, the number of things in scores that are equal to 10.
What would be the type of number?
It will actually be standard size T, because that's what count returns. It's a more general type than, well, no, strictly speaking, it'll be the, no, it's the size type of the vector, which is size T. That's not really worth going into now. That's why I used auto here. But it's going to be an integer type, which is really what we want. But it handles having more than 4 billion of things, which an int wouldn't. And we can do the same thing for our dog names. This time, yes, we've got a vector of strings, but our call is exactly the same. We count the number of things in this names vector that are equal to Rover. And you can probably guess at this point what's coming next. We have our nice array of switches. And we can just count the number of things, the number of elements in our switches array which are true. So this is pretty nice. We've had those loops that we had to write manually over and over again. You know, you probably, if you've got a large code base, you imagine how many times that sort of thing occurs. And here we just replaced it with one function call. Yeah.
So for the vectors, why have you created them to a function? Equals get sources and get domains.
Just because I want you to imagine that that's some function that exists that gives you the score. It doesn't really matter what it writes. This is just an imaginary function that supplies scores or supplies dog names or supplies the state of the switches. It doesn't really matter. It's just saves me having to like do scores open bracket 1 to 19, whatever. So we've used this nano count function. And we've reduced the repetition in our code. I mean, it's a pretty bizarre code base that handles test scores and dog names and switches, but you get the idea. We're not repeating ourselves anymore. We're just using this one useful function. And more than that, we can avoid bugs and improve performance by reusing a function that somebody else has written. Now, again, count's simple enough that our code, our nice little loop was already pretty efficient. But if you're doing something a bit more complicated, let's say you want to, say you have a list of strings and you have a big list of big strings, a smaller list of strings, you want to see whether all of those things in the small list exist in the big list. That's something that's actually not trivial to do. And it's especially not trivial to do efficiently. And yet there are people out there who have written these libraries that do that very efficiently, very well. And perhaps most importantly, we've made our code, as I say, more expressive. We've expressed the intention of what we were trying to do. The previous slide you saw, it just said count. It said count how many things are equal to Rover, how many of the strings are equal to Rover. It's there written in the source code, whereas previously somebody else who's coming along and trying to read that code would have to recognize what that for loop was trying to do. So count is a simple example, probably the simplest example. But there is a library that exists that has masses and masses of these algorithms, as we call them. Count is an algorithm. And the C++ standard library has tons of them. I think it's a little over 90, I think it's 92 at the last count. There are lots and lots and lots of standard library algorithms that do all these simple, repetitive things. Well, they do all the simple things. They do some really complicated things as well, like sorting. I challenge you to write an efficient sort one that's as efficient as the standard library implementations. So I used nano count for reasons that we'll get to, but it's just an implementation of, or re-implementation of something that already exists in the standard library. It's a little more wordy to use it in the standard library. But all of these algorithms already exist, and they're there waiting for you to use them. They exist in a part of the standard library that deals with containers and algorithms and iterators, which are the glue between the containers and the algorithms. And that part of the standard library is commonly referred to as the STL. Now, the STL has been around for a while. So it was originally, before there even was a standard C++, before the first standard had been published, a guy called Alexander Stepanov, Russian mathematician, he was working for Hewlett-Packard, or HP's R&D department. And he came up with this idea for a library of reusable algorithms. And then he, together with one of his colleagues, Meng Li, published this paper and the accompanying code that defined what they called the standard template library. So this first came out in 1994, which makes it sort of older than Justin. And I wasn't into C++ programming at the time, but everything that I've read about that is that the publication of this was absolutely, completely revolutionary. So up until that time, C++ had just been seen as kind of an object-oriented language, because this was the early mid-90s and object-oriented stuff was really fancy, was really in vogue, and Java was going to be released a year later. And C++ was seen as what it originally started out as, a set of object-oriented extensions to C. And then Stepanov came along and he invented this standard template library, and it transformed people's ideas of what could be done with C++. It invented, well, Stepanov said he didn't invent it, but everyone credits him with it, invented this idea of what they call generic programming. So HP's original STL library is actually still available. The source code is still available on GitHub in various places if you search for it. But the bulk of their library was incorporated into the first version of the C++ standard library. So the first C++ standard was published in 1998 and included a specification for an accompanying standard library. And a lot of that standard library was imported from HP's, from Stepanov's standard template library. And as I've already said, it's really common today to refer to the containers and algorithms, the bit Stepanov invented, to refer to that as the STL. It's technically incorrect, and you'll sometimes get really pedantic, whiny people who go, well, no, STL refers to this old 1994 thing, but I don't care. It's so common, and if that really bothers you, you can just think of STL as standard library, like with ST for the beginning of standard, if that makes you happier. So the STL provided a load of containers, about a dozen of them, I think, Really common things, vectors, what we know today is standard vector, linked lists, associative arrays, queues, decks, sets, multi-sets, lots and lots of containers on the one hand, and on the other hand, algorithms, these functions like count that operate on the containers. And there were some support facilities as well, which we'll go into in the coming weeks. But what was really important, really quite revolutionary about what Stepanov did was that he used this facility that's in C++ called templates to effectively decouple the containers from the algorithms. So we haven't really talked very much about templates in this class. I mentioned that, right at the beginning, I mentioned that standard vector is a template, is a class template. But a template is like a blueprint for how you write either a function or a class, or a couple of other things can be templated now, but mostly functions and classes. So it's like a blueprint for how you would produce this function, how you would produce this class. And so all those algorithms like count that you saw there, that is a template. And when you actually invoke that, when you pass it some arguments, the compiler goes away and it looks at the blueprint and it goes, okay, I'm now going to produce a function that is specialized just for this thing you've given me. So count, we called it with a vector of ints, and then we called it again with a vector of strings. That produced two different functions from those blueprints in the actual assembly code that gets generated. That produced two different implementations. One that was specialized just for vectors of ints, and the other one that was specialized just for vectors of strings, and then a third one that was specialized for array of bool. We literally call these things specializations. And because the compiler has all the information there, it knows exactly the value type, it knows the container type, it knows all these things, it can optimize insanely well. Which means that using these algorithms, using these templates, using this generic code is absolutely as efficient as it would be if you wrote it yourself. So again, I'm going to go more deeply into templates in a few sessions, but they look and sometimes feel superficially similar to generics in Java, for example. But they work very, very differently because generics operate on a form of type erasure and they just produce one version of the class but with sort of the information about this specific type hidden away. Whereas C++ templates are very, very different. They actually produce a new specialized function or a new specialized class. Right?
Generics are a runtime. Templates are not.
Yeah. So templates are staggeringly complicated, but very, very powerful. And they are the key to the STL. So before Stepanov had come along and done this, it was really common to implement specialized algorithms for every container. So standard string is an example of something that existed before the STL. It's been around for longer than the STL has. So you'll notice that there are lots of functions like string.find, string.replace. It has these specialized implementations just for that container. And you can imagine we could hypothetically have, if we wanted to sort a vector, we could write a vector member function called sort. Well, then if you want to sort a vector, you probably want to sort an array as well, and well, probably want to sort some strings, sort strings, don't we? So you can imagine you've got to write the same function, the same algorithm again and again for each type of container you want to use. That's going to be a lot of work. if you have n different containers and m different algorithms, you've got to write each algorithm for each container. That's going to be n times n implementations. It's a lot of work.
So if someone done that for you, is that just done it once to make the template as such, so he knows where to go? Is that how it works?
So instead of manually going and writing all of these n times m implementations, so instead of writing a version of sort for vectors, writing a version of sort for strings, writing a version of sort for arrays, somebody went and wrote a generic version of sort that can operate on any sort of compatible container. And more than that, thanks to this power of templates and specializations and giving the compiler all the information right there up front, it means that these things are 100% as efficient in terms of runtime speed and in terms of memory use, exactly as efficient as if we'd implemented them directly. So with these generic algorithms, with these generic functions, we can just write each algorithm once, but make it generic, make it a template. So we've written m different algorithm templates, 90 of them-ish, roughly, and about a dozen different containers. So we've had to write a bit over 100 different things, which is still quite a bit, but it's a lot less than 12 times 90, whatever that would be, that we would have to, sorry?
1080.
1080, oh, well done, yeah. So more than 10 times as many things we'd have to write if we did it the other way around. So this is really the sort of magic behind the STL. It's this idea of writing your generic algorithms and then that code being able to adapt itself to any sort of container that you want to run this algorithm on. It is really, really just... I can't imagine how this must have seemed if you were a C++ programmer reading this in 1994, because it must have been mind-blowing.
Does it basically then direct you to the right sort of something, this generic version?
So,
as in, how does it work under the hood?
how does it work under the hood? Okay, so let's see the example of count. So you call count on a vector of bits.
Yes.
What it does, so count is a template, it's a blueprint for how you write that for loop.
Yeah.
Right? So what it will do, it will actually produce, so that's a blueprint, it's not a real function, but once it knows the arguments, once it knows what are called the template arguments, it will go and it will produce a function just for vectors of ints. And vector is itself a template, so the compiler can see exactly how all these things are implemented, and it can bring the absolute full weight of all its possible optimizations, just specifically for counting vectors of ints. And then it does the same thing when you implement, when you call count for a vector of strings. It produces another function, a specialization, as we call it, of count for vectors of strings. And then a third one for arrays of bools. And whatever other container and value type combination you want to give it. So we're going to delve a little bit into the future. What I was talking about there, that's the dim and distant past, 1994, a while ago now. Well, 1994 was the sort of initial paper, and then they spent 4 years kind of polishing it and choosing which bits of it they wanted to bring into the standard library. So, been largely unchanged since 1998. There were a few additions, a couple of new algorithms in 11 and in 14, but fundamentally, things haven't really changed in 20 years. In C++20, we're going to get a load of new stuff. C++20 is going to, all the old stuff is still going to be there, it's not going away, but C++20 is going to add a lot of sort of more modern ways of interfacing with this. And you can really think of the new C++20 editions as STL 2.0. So it's like a 2.0 release of software. You know, we've learned from the 20-year-old version, we've polished it, we've made things, yes?
Sorry, I'm just thinking. You know, we did the count thing.
Yeah.
Well, we've got standard containers. This only works for standard. This only works for standard objects as well.
No, I'm not sure I'll have time to talk about it today, but it works for anything that meets what we can call the container requirements. So, like you can think of it like the container protocol.
So if I had I don't know, I had a class called aliens and a vector of aliens, I want to know.
Yeah, that would work absolutely fine. Yeah. Yeah. Or if you had your own kind of container. As long as your container, as long as you've written your container in such a way that it adheres to this range protocol or concept as it's called in C++, then you can use it with the standard algorithms.
So I can make my class just to meet, but it has to meet certain requirements.
It has to meet certain requirements, yes, and we'll talk about those. But probably not today. Well, definitely not. So C++20, we're getting a load of new stuff. It goes under the name ranges. So with the existing STL, you have to sort of manually provide the beginning and the end of the range, which is a bit annoying. The C++20 facilities will let you do what you saw on those slides and just pass the range as a single object. You can optionally still manually pass the beginning and an end of a range, beginning and then end of the container. But C++20, the new facilities will make things a bit nicer, a bit syntactically simpler. So that example with count you saw, I did this hash include nano range thing, and then I called nano : : count. The reason for that is just because I really like the new stuff and I'm really excited and I want to use it. So I went and wrote this library that I called nano range that implements these new C++20 things. So we'll be using this just for today, just because it makes things easier. But from next week onwards, we're just going to use the actual existing standard library. It's just today, because the new facilities make things nicer to look at, I thought I'd use the new stuff that's going to be coming in a couple of years. But from next week onwards, we'll be using the traditional STL instead. But if you want to continue using this fancy new stuff for exercises and things like that, I don't mind at all. That'd be great. You can help me find bugs. It'd be wonderful. So I mentioned that the standard library provides about, well, over 90 of these algorithms, ranging from the very simple things like count, things like find, things that you could do it efficiently is very hard. The algorithm header. So, in the remaining 22 minutes, I've got a bit of a task for you. If you go to this URL, you should be able to find some code that I wrote that gives you a chance to, first of all, look for algorithms that you can use. These are tasks that you can mostly do yourself by writing for loops, and perhaps that would be a good way to start. But what I want you to do after that is to try and find an appropriate algorithm to use from this library that is available to solve these. There are only two problems. Fingers crossed that URL works, if somebody can tell me. Yeah? So if you can clone, download, whatever you'd like to do with that code, and have a go at the problems, and then, well, we've got 20 minutes left, so we'll see how long it takes you to have a go at that. That's a good question. So, yeah, it takes forever. The first one, yeah, it does. You can still open. Okay, I can still do it. I understand.
Quick question. Not to this new exercise, but how do I upload things from Xenon back into
Okay, so have you
So I've already cloned it.
cloned it? Have you
It's on my
forked it into your?
I have no idea. Well, I don't know.
So if you go to the so if it was one of the things I did via GitHub Classroom,
Yes.
yes, you already have your own repository.
So I've already got to check it out. Yeah.
So if you create, if you commit new things, commit something new.
New project.
You have to select the files that you want to load. No, that's just as an unversion file. Sure to try to. Through this time.
Idea of it.
Is it last week's exercise or this week's?
I just want to upload them back onto my GitHub or the branch.
So you need to fork his repository.
No, so this was via GitHub Classroom, so it actually
automatically
gives you your own repo that you can play with. So if you just, yeah, so you've got a commit message in there. So
Okay, then check your remotes.
just click commit. So you want to commit it locally first of all. So just for example, so just go to commit. And now I see here.
I'm done.
Oh, so
Okay, so you have to.
Just straight away.
You go to BCS, it's generated.
So when I first got the link, I
You haven't got include.
Oh, is that
So you just need to include.
in May?
Oh, okay. You have got a commit. So it's
Where
in
it is.
exercise. So,
I did that before coming in.
okay,
So I
so,
can't see it online.
okay, so you have got the commit. So now what you want to do is upload that commit. So,
Yeah, so check for remotes. So get remote dash bit in the tunnel, and then you want to check that you're pointing towards your origin.
So I thought this does now update project control T.
so what happens if you press that?
numbers CPP.
This goes out update type merge rebase branch.
Merge rebases. Well, okay, this is. I'll cancel that a second. If you go to BCS. I'll push. So, push. Okay, push. It's just thinking. Can I ask you for a password?
I think I'll be fine.
Okay, so now if you go to GitHub.com, your browser, you should be able to see your new.
But then it replaces your original file. Mine.
Yes, but if you go to your previous commits,
Oh,
you'll see.
thank you.
It's quite clever. The YouTube app gave me a notification
Yeah, if you subscribe.
that something I subscribe to now has a new live, watch live now on C++ the new Virtual 3 SML. Which is, perhaps I should do that. Perhaps I should stand and be like some sort of feedback loop. The internet crash. Okay, so just to say, you don't have to modify anything in the words or in the random numbers. You don't have to modify those in any way. They're just there to give you some data. Don't worry about that. You only have to, if you look in main.cpp, there are two functions in there, and you just have to add some stuff to those two functions. I even put a little comment to tell you where to add the stuff. Sorry, you had your hand up. Oh, you just switched.
I have a question.
Yeah, of course. All right.
I can't get mine to compile, but I'm wondering maybe if it's just those Visual Studio.
Is it because it's too small? How do you live with that? That's the best eyesight in the world.
I've got glasses. No. So I added that.
Okay, that's not necessary. Okay. So are you first of all, are you using like
Like the latest one. I'm not sure. I did update it fairly recently. So I don't know.
did you open this as a CNAME?
I just clicked the button and said open Visual Studio.
So we're going to use this nano range library to print this first exercise. Is that the idea? It's just the new latest.
Yeah.
Then it says
Wait,
size
go,
one.
go, go, go.
I think you clicked OK.
It's up to you. Yeah.
But the whole point was to use these things.
Nano range.
No, not nano range. Almost use this algorithm.
Nano range is hard to C++.
Yes.
Interesting.
Yes.
If you want to use it, you can. You don't have to. Depends how you
opening as a CMake
Yeah,
file.
open it as CMake, and then it might give you an executable that you can.
Okay. So you got it right. It's using
Sorry, median is like average value, yes?
It's a particular type of average. So the median is, if you list all the things in order, it's the one in the middle. Or list them all in order from smallest to largest, it's the one in the middle. So for example, the median of 3, 3 and 5, write those in order, it's 3, 3, 5, the middle one is 3.
makes sense.
If 1, 2, 3, 4, 5, the median is 3.
If there's 10, if there's, well actually, if there's 11 values, if it's an even number, then it's a bit. What's the rule?
Yeah,
of
actually,
even number?
well, sometimes you take the mean of the two middle values, but I'm happy with people just to take the.
So if there's 11 values, right? It's 5 either side of the middle value, right? So that's that when they're sorted. You get one, where's one in
Are we meant to use normal?
You can use the
Are we
normal
meant to use
SQL
our-
things if you want to, if you're comfortable doing begin and end everywhere. I just gave you a copy of my library just so you didn't have to just see each other.
So we're meant to use this.
So no, you need to use sort the vector.
Well, possibly a good way to do it would be to first of all implement it yourself with a for loop if you want to, and then try and find an algorithm that would be appropriate. That's one way to do it.
Is it essential?
That's probably quite a good way to do it.
Thank you.
No, but you can.
I think the natural is correct. Well, might as well put words in there as well.
No, of course.
I think it's not very like
So I was going to ask you how to use
It's annoying, I know.
give me a few guidance tips.
So let me run mask because I don't use it at all. I use
Wait, is that
Yes, so
actually
everyone tells me.
Oh, yes.
standard function?
There's no wrong way to
So
use it. If you want to use
so
it,
you should have me to do this checkout thing, which is
Okay, so you sorted your.
type in the URL, checking out, typing in. Now, let's say I've checked something out. Now I'll check it back in. Yeah, you're right. Of course, they create yes.
well, you have no, you just have your local copy.
No, I'm not happy. I mean, that's fine.
Oh, sorry. Is that, oh, that's, no.
You do it without sorting the array of random numbers.
Not this one.
It's not this
but
one.
the
Oh, yeah,
other
right,
one.
yeah, that's fine.
So you can actually just do that.
Yeah. So
So,
S is
but how do I
the
then
collection.
find it? This is the
And then
link.
okay. Use that.
Why don't I
And then
No,
yeah, right.
Okay, because
How do I
sorting is a
find
very
it again
extensive
from my main-
Okay.
So,
Yeah, it's a quick copy and paste.
I've given you that one. So I'll give you an array of 100 numbers. Imagine if it was an array of 10 million. Sorting that would be putting all of those numbers in the right order, just to find the lowest, the highest, and the middle, would be overkill. You don't
But when I
need
used to go to one, is this one? I was go to the user console.
Okay, but if you're writing a video, you've got
No, I'm joking.
60 for the second to do things, you want them to make them as efficient as possible. If you're writing some mobile phone software,
Oh no, because it's not physically yours. That's
more
something
processor
physically
time
your username. Whereas some
you
you can
use, the
access
faster.
to.
This is my actual
User
story.
battery.
Yeah, mine was
Yes.
fired.
Yes.
What you do is run it.
Yeah, so you sort vector before.
Because sorting is the natural thing, you know. Otherwise, how do you know what's the biggest?
And then
You could go through
It's
like compare, yeah, like
Because it lives
bubble
under us,
sort or
you have
something
access,
like
you
that.
have right access to bubble sort.
Quick
Yeah.
sort
Yeah.
or
Forget about, just for the
No,
forget about
That's fine, that's the decaffeination.
No, but then how do I find it in the file?
From that
I mean, it is sorting anyway. You will sort it,
yeah, I'm saying one.
okay?
Yeah, doing that.
I'll just give you a bunch of
So now
numbers.
that we've done it before,
The best way to
I'd
access
say
it
what's
is
high
if I do it with
the
range,
password.
you think that it's actually the same thing.
Just
Well, the only way to make sure that, yeah, I would only do it via sort, because, you know, how do I know if the number is,
You don't have to sort it to check every number.
well, I can, yeah, but that's, is same
Asking around
expensive
the
was.
delete from
You're not copying anything.
Let's just
moving around and doing. You're not copying.
So I love Git.
So it's to compare the current number against the next number, and if the next number is bigger, then take this and you just group up.
Are you doing exercise 2 already?
I'm sorry.
Sorting is quite an expensive thing to do.
No,
Move every single
Oh,
element,
the stuff.
shuffle them all
Oh,
around
I'm
to
looking at the
right
readme.
place.
So you're just going
there's a
through.
nice way.
I
to
said-
the name.
Okay, okay.
There's a nice way to get.
So that it's possible to find the highest value or the lowest value without
You need to do it by your
shuffling
activity.
any elements. Moving and finding the highest value of a constant.
Pushing it back up regardless if it was a classroom
I
or
would
Yeah.
say
Okay.
Just take whatever the latest updates are. So, okay. Just temporary.
yeah, standard load.
That should work.
Standard library. Okay. Was there a hand up?
Thank you. Yeah, I still seem to be getting the same errors.
what does commit do? What does that do?
Oh, commit's like commit just commits the changes. So when you make changes, right?
Like,
They're
C9
not tracked.
automatically.
No, it saves the files, but it's not tracked in Git. Git doesn't. Git knows they Git
Does version.
Git shows that they've changed, but you have to submit to Git.
Sorry,
But the new version, so it's like a new version.
So it's like it's a new point in time. So each commit,
Yeah,
you
I've
make
just
commit
been
is
using.
an object that's
Yeah,
pointing
no,
in
that's
time,
okay.
and it's a child of the previous
Sure.
point in time.
But I couldn't figure out.
You have
So
to
that's
make
what commit does. So what does update project?
Exercise 1.
There's other options in update project.
I don't know, that's not
I
Git.
think
No, it says Git.
internally it might do some pull.
No, it's just a pull command. I don't trust this.
Yeah, it's a separate command.
I would Google it. That's definitely something that they've invented. See, right?
Yeah,
You won't be able to use the fancy use the latest.
There is literally a pull.
Yeah, it's a separate option.
I just do, possible. That could be a they have a rebase option.
Yes, it comes up saying merge, rebase, or
So when you do update project,
yes.
then it's flexible. It's more flexible. So you can choose to
It says branch, merge,
yeah.
rebase.
It gives you so that makes sense.
So which option would I choose? To just push it back up as a new version.
Depends on your team's workload. So some teams like to if you're out of date, you can diverge and let us know. And then another way to do it is
The merge is going into the main branch.
no, so yes, but
Basically take the main branch and apply it to your local changes. So for
create
example,
merge.
if you work
Yeah,
for example,
now
you
you-
work in branch,
now
and
you-
if the branch you're working on has more commits at the moment, you can basically apply these commits in your branch, either by merging it, you apply all the commits you've got from there
It doesn't matter. If you want to use the standard library, that's fine. I just gave you mine because it makes it sort of syntactically easier.
So I just see an STL 2.0.
Oh, I've gone back too far. Hang on. I'm going to have to go through all of these, sorry. So these are all the same algorithms that are available in the standard library, except in the standard library, for reasons we'll now get into next week, you can't just pass scores, you have to do scores.begin and scores.end, for example. So the reason I've given you this library is just so that you don't have to type this begin and end. Don't have to worry too much about that today. But from next week onwards, all my examples are going to use the traditional STL.
That's why
That's what it is. If you think about what a new major release of some software gives you, new features, bugs fixed, slight incompatibility in some ways. Nothing's breaking because all the old, the old stuff is still there. What's changed subtly is the iterator constant requirements.
Yeah, but
Particularly default constructability is going to be big.
there was going to be an STL2 namespace.
No, it's in the subnamespace. It's in standard ranges.
So, am I using this right?
So what do you want to do? What's the name of the algorithm you want to do? Which one?
So you're going to iterate through the words.
Trying to iterate through.
Yeah.
Okay.
So
So the easiest way to do that is just an for loop. You don't need an algorithm. You're just trying to loop over them and print them all. Is that what you want to do? Print them?
yeah.
We're not using you can use zero.
Can we do that using elements? Because we've done it already.
You can. So you can use a function called copy. Although it's a little bit tricky. It's not obvious how to do it.
Well, since you've said that, I'm not doing it. It's tricky for you.
No, it's not tricky. It's just it's kind of one of those things somebody has to show you. You can't sort of come up with it.
It's not intuitive.
Sorry,
It's not intuitive.
it's not intuitive.
So what's the operand?
Denominator or the, you know what I mean?
So for the printing,
If it's wrong,
you can just use a for loop. Yeah, it's fine. But very good thinking that you want to use an algorithm to do it. I really like that thinking. That's exactly the right intuition. Exactly the right intuition to go. Well, printing the whole list of things. That's just an algorithm. There is a for each function. There is a for each algorithm. We have to pass in the function and performs.
so that
So for each, you give it the range and a function, and it applies that function to every element of the range. So if that function printed something out, that would be a way to do it.
So you use
That makes sense.
Tristan,
So
you do
force.
you int say size t divided by double.
Yeah.
Result is still a size t, isn't
No, size t divided by double would be a double.
it? Still a double.
Yeah.
It's okay.
Sorry, there's another thing I was thinking about.
what about size t divided by
At the other side.
Is that not min?
You need a double colon.
No, the left hand. Left hand side is floating point.
Do I do the same
Right
thing?
hand
Yeah,
side
words
is
begin,
whole number.
numbers begin.
It's evaluating.
What end?
I'm not so sure. Yeah, I mean,
Just trying to just put that to stand up.
It's just if you have any number, you have to go.
Given that conversation, and mine something happened like 2 weeks ago, 2 weeks ago, we're required to do something.
No, just try to change it to nano instead.
Nano?
Instead of STP.
Division on its and the return type was double, and it managed to return a double.
Because this really should work.
It's how did that happen?
No, just try running it, because sometimes
I can show you on my
C line
computer.
claims their errors.
Probably easier to explain.
So I have to change the back of the thing as well. Let's do this.
So, min return to
As long as one side is
short version, just put a star.
I'm looking at the median number, so the median is giving you a bit of the array.
Oh, I see.
So you have to dereference the iterate, you have to see the value. No, we'll just try this.
Is that dereferencing the thing?
Yes, that's dereferencing the iterate.
It wasn't that, maybe it's a reference.
Yeah, like an object that points to.
Didn't know you could dereference it.
Yeah, well, we'll talk about that quite a lot next week. That's what next week's going to be all about. In fact, it's 6 minutes past 21. Kesha's desperate to get to the pub. He's tidied up and is standing up already. Everyone seems to be quite into this, so I'm kind of reluctant to draw a close to it, but it is past time, so we're going to have to call it a night. Yes.
To do with this, but can you put up last week's slides?
Last week's slides. Oh yes, I will. Sorry, yes, I completely forgot. So thank you very much, everybody. Next week we're back here again, so you will have to register on our website again. Otherwise, if you want to go away and continue with that this week, or perhaps you want to have a go at Advent of Code, if you want some fun, Advent of Code is a really good place to practice using the STL algorithms, by the way. So that's all for this week. Thank you very much for coming, and see you next week.